Hello there. We now reach to PLC timing function. So with PLC, there's no physical contact or the coil. So in PLC, we use tag to represent all the data associated with timers. And also, we have correspond to the two different type of timers, on delay and off delay. We have two basic instructions. Right, so let's look at the details on the timer. Right, so with the PLC tag, right, so we create a new tag with the data type of timer. So it's the same way as the before if we have the PLC tag as a Boolean or double integer. Right, so over here on the picture you can see once you create a legal name, it doesn't have to be T1, or it could be any legal name, and the most important part is that you need to specify the tag data type as the timer. So once you create a timer type of tag, you have a structure. So if you open this T1, within that you will see below this T1 you have a structure with different members. So you have two double integer. It's a combination of a Boolean and a double integer, right? So you have two double integer tag. One is called preset, so how long you want the timer to run. The other one is accumulate, ACC, accumulation of the timing. So both of them has the T1 as the owner. So you can see the T1 dot at the front. Right. So same thing for the other three Boolean tags. So we have three control bits. So one is called enable, the other one is called TT, timer timing, and the third one is called done. We'll look at those in details on there. So the only thing you need to remember that, so you only need to specify the name for the whole structure for the timer. So once we specify that, you automatically have those 5 members within the structure. Right. So let's go to the next page. So first we can look at the timer on delay. So this is a TON, that's a new instruction. So within this instruction you have a box, right? So within the box you can see there's 3 parameters. The first one, you need to specify the timer tag. So you use this T1 to associate with this TON instruction. So you want to set up the timing with a number. So right now it's 5,000. The unit for the preset is millimeter. So that basically that's 5 seconds. Then the accumulate start from 0 when it's running, and that will start to increase until it reach to 5,000. Right. So that's happen when the trigger is on. Right. Of course. So outside of the box, you can see here there are two members showing also showing on here. One is enable, the other one is done bit. So we know there's another one it didn't show on here called TT, so timer timing. So that's the 5 members within the timer structure. So in the program you can use the bit instruction exam on, exam off to check those 3 Boolean members. So whenever you use the EN bit, enable bit, you need to remember this bit always follow the trigger. So when the trigger is on, start the timing. So the timer is enabled, so that one is on. Right. So it's like a timer immediate output. So if you remember, sometimes on the relay ladder logic, we parallel with timer. For example, if this is a timer, so we parallel the timer with a control relay, and some of the circuit I explained that, right? So that's in the hardware, right? So in the PLC, we don't need this. We don't need automatically. It has a enable bit as the immediate output, right? So it doesn't need to have the control relay in parallel with timer anymore. All right, the TT timer timing. So that means timer started but not done yet, right? So that's the one type of logic you can get from the TT bit, and then I'll explain that in the program and demonstrate that. All right, the done bit is the timer delayed output. If you remember, with the on delay, we have two different type of the contact, right? So with on delay, you have the normally open. I'll just draw in this format, timed close, or the other one is normally closed, timed open, right? So those are the two type of contact we learned in the physical timer relay. So with PLC, we just drop those letters. We directly use exam on for the done bit. That will give you the normally open. You can see here, normally open, timed close, right? Because we drop the TC letter. So we directly, because exam on can operate on the Boolean number. And on the offset, it's up here, right? So if you use exam off, then you get normally closed, timed open function. So what you learned from the timer, you can continue to use here in the PLC, right? It just represent in different format. All the logic are the same, right? So there's one more thing over here. So you can see here, I has a comment about that. The enable bit is a convenience reference when the trigger is combination of multiple conditions. What I mean is over here. So if, for example, if you like in the, what you seeing over here, you only have one tag as the trigger. That's very simple, right? That seems the enable bit is a little bit redundant. So whenever you need this enable bit, you can also use the trigger to do that, right? So that's a simple trigger. But if you have a combination of other conditions, for example, like over here, you may have something on here, and then maybe there's another condition on here or something that it's a combination of trigger. So in that situation, this enable bit is more convenient, right? It's the result of those combinations, right? So that's something you can keep that in mind. All right. So that's the control bits and also the logic we can get from there. Then let's look at a demo of the on delay timer on here. Okay, so let me open the on delay. All right, so it's identical, almost identical to the slide. All right, so let's look at over here. So we have a trigger start T1 5000, and over here I just put a empty run. This is NOP, represent no operation. It's just a placeholder. So I want you to observe the changes on those bits while the timer is running. All right, and then we'll look at those here. So first, let's start the timer. So notice the accumulation is 0. So once I toggle the bit on the trigger, the accumulation will go up. Timer start timing. And when that happens, you will see the enable bit turn on immediately because that always follow the trigger. And then in the same time, you will see the TT bit, right? Timer timing will turn on, right? And before reach 5000, that's what you see: EN bit on and timer timing on. And when the accumulation reach to the 5000, you will see the done bit on. And then in the same time, the timer timing will be false because you already finished the timing, right? So what I have, this parallel branch is here. I want you to observe, look at there. The TT bit basically is the combination of timer enabled but not done. You will see whenever these two are true, together it's true, right? So let's look at on here. If I toggle the bit, start the timer, you can see enable is on, TT is on, right? This two is on, and then that reach to 5,000, right? Before reach 5,000, that's off, right? So now it's done. Because I'm using an emulator that's not very accurate, reach to 5,000 with the real PLC controller, that should stop at 5,000, not 510. All right. So when the accumulation reach to 5,000, the timer timing become false, right? Then you can see here, this one, because it's false, it's not true. So I just want you to understand this is equivalent of these two together, right? So when the trigger is true, you can see that is what is holding. If I toggle off, when trigger is off, everything reset to 0, right? Accumulate, reset to 0, and all the control bits go back to the initial position, right? So that's the control bit. If maybe I should make that longer, so you can have a longer time to observe that. Let's look at maybe just 9,000. So that'd be 9 seconds, right? So that's I'm gonna trigger this one again, so you can see the changes with that. All right, so let's toggle. It's going up, right? And then enable is on, TT is on. Done bit is waiting for 9,000, 9 seconds, right? So once you reach 9 seconds, the enable is still on because trigger is still on, but the timer finished the timing. Right? There's no TT bit anymore, right? So this is the three basic bits. You can use control on that, and then if I toggle that, that's gonna be 0 again. So mostly with the timing function, we will use the done bit, right? I explained that. So done bit represents the timer delayed output. That depends on which instruction you use, right? If you use the exam on, that will give you the normally open time close function. So you can consider this instruction, right, as the normally open time close contact, right? This one looks like the normally close time open contact, and then if you use that in the logic, you will get the same timing function like that. So like right now, timer is off, right? You can consider this T1 as the coil. When coil is de-energized, right, nothing is running, the normally open, right, time close is open. Normally close, time open, right now is closed. That's what you see this over here. When I toggle that, start timing, that will now change before reach to 5,000. Once reach to 5,000, they're gonna flip. So the done bit is on, it changed to 1. So that's why you see that this one become true. The exam off become false. Alright, so I'm gonna do the demo again. So clear to 0, then trigger on that. So once reach to 5,000 accumulation, then you can see the change out there. Alright, so this is the basic operation with the TON. So let's look at the more details on other parts. Alright, so on this slide, I think I already did this one, the demonstration between the TT bit of this two combination, right? So the second point on here, remember that timer also has two double integer members, right? Accumulate and preset. So of course you can use those member in the double integer instruction, right? So like over here, you can use that in compare, greater or equal, right? So for example, if you want to compare the accumulate with the 2500, remember 5000 is the preset, right? So whenever this accumulation greater or equals to 2500, basically half of the 5000, you can output a indicator. That means that because timer doesn't have the half done indicator, right? So you can create your own halfway done indicator on here, right? The other example you can see on here. So with the preset T1.preset, you can change the value on here. So like over here, it has 20,000. You make the timer longer, right? Whenever you want to extend the timing period, currently it's 5,000, right? So whenever if you want to, for example, this it could be a push button, right, or any condition. When this one become true, you basically copy, you move this 20,000 into the preset. That's why you make the timer extend the timing period, make it longer, right? And of course, with both double integer members, you can always use the CLR. CLR equivalent to move 0 to the value, right? So, for example, you can halfway in between, in the middle of timer, you can clear the accumulate, so that the timer to restart again, something like that, right? So that is something you can operate with the double integer. So the third point I want to talk about with the on delay is that it has a RES instruction. This RES instruction not only associated with timer on instruction, it also will work with other timers, right? Timer off and other retentive timer I'm going to talk about on the next slide. And also the RES also used for counter. We're going to talk about the application of the RES with counter again later. Right, the instruction format is just a bracket with a RES letters in there, right? So you basically reset T1. So whenever this condition is true, you use the RES to clear the structure of T1. So whenever that being executed, the structure of timer will like accumulate, change to 0. All the control bits change to 0, right? So what I mean by here is that normally on the demo, you remember that you can use trigger to turn it off, right? So whenever trigger is off, the timer is reset, right? So this is just two different ways to reset the timer. So you may think, okay, it looks like this RES instruction doesn't mean a lot, but it has its very important function for the next instruction. That's what we talk about with the retentive time on, right? So over here is just a brief descriptions of the RES, right? So that's you can read that, all right? So let's move on to the RTO. So RTO is a different type of timer, right? So RTO basically is the same as TON, except, as you can see here, right? So except the RTO, R represent retentive. So except the accumulate value doesn't reset to 0 when the trigger is off, right? So I can demonstrate that on there. So remember, if it's not RTO, if it's TON, so the timer is enabled by the trigger. Whenever the trigger becomes false, the timer clear to 0. But if you use RTO, retentive, this accumulation doesn't change. Even you can see here, I make another comments on here. Even when you have power cycle, that means even your PLC lose power, and inside PLC it has memory. The battery will keep those part of memory. Whenever you power back on, that accumulated value is still there, so that can keep going, right? So that's a special part of the RTO. So you understand that, then you know, okay, the RES is very important with the RTO instruction, because that's the only way you can clear the RTO timer into 0, right? So let's look at the demo again. All right, so before I move on to the RTO, let's look at the TON again. Like right now, you can see the accumulate is 5,000 because the trigger is true. If I toggle that, so that's automatically turned to 0, right? Even in the middle, if I trigger that again. Let's start over here. Then if I clear that, right, before it reach to 2943 something over there, right, you can see whenever that become off, become false, that clear to 0. This is what happened with TON. Right. Let me switch to the RTO because I need to call different subroutine, or I need to change it here. So now let's look at the RTO. So this is RTO instruction. So I have a different tag called T2 associated with here. So the preset is 20,000. Right. So you can see if I trigger that, it start to increase. Right. Then if I toggle off, you can see that accumulation reach to 3379. Right. That stays there. It doesn't clear to 0. But notice the trigger is already off. Right. So next time when you turn on the trigger, that will continue from the previous result, continue to increase on there. Right. If you stop again, then it just stop where it was. Right. 11,823. Right. So that's where it stops. Then when you turn on again, that will continue from the 11,000 and continue go on. So you can think of this application, right? For example, if you want keep track some equipment or some component, how long it has been running, whenever the power on PLC is running, you can use the RTO, right, to record like how long this equipment has been running. Maybe after 10 days it needs some maintenance or maybe something else, right? So you can think of that type of the application with RTO, right? So it's just a special type of timer on delay. Though, so like I mentioned, right, the RES basically is the only way you can clear the accumulated value to 0. I shouldn't say the only way. Remember, because they are double integers, right? You can also use the double integer instruction to modify the value, right? So yeah, that back off a little bit. I shouldn't say only way, but now you can see the function of RES. So if I toggle this, the RES gonna be executed, and then that will reset T2. You will see this accumulation value change to 0. Toggle that change to 0, right? So this is the second type of timer called RTO. All right. So it's, like I said, it's just a special type of on delay. All right. So let's look at the timer off. All right. Timer off delay, and you know what? Let's just continue work with the program. Look at the demo first, then we'll look at the slide. All right. So over here, because I want to run the TOF, so I have to change this one to 30. It's just for me to keep track different subroutines. Now we are calling this TOF. So R30. So that's the timer off delay. Right. So if you remember the off delay, right? So the timer will not start timing when the trigger become off. So you can see here right now trigger it is off, and it's just because it's from the previous running, right? It just finished a long time ago. So whenever I turn on the trigger, when this one become true, you will see the accumulation change to 0, right? Remember, it's off delay, right? What you see over here, this 5,000 is from the previous execution. It finished the timing, right? So when I trigger that to true, the timer off will be clear. It will wait for the trigger become off again, right? Let me try to see here. When I trigger this, you can see the accumulation become 0. Then also you can see the enable bit. Remember, enable bit always follow the trigger. Right? When trigger is true, enable is true. But the timer timing is off. You can see the accumulation is not changing, right? So that means timer is not timing, right? It's just reset to 0. And then from the done bit, you can see here again the done bit is the timed output, So for this, you can consider this as normally open, time open, right? So because the trigger is on, right? Trigger is on, the coil is on, so normally open become closed. That's why you see the green bar being highlighted, so that's closed. Alright, so the opposite you can see here, that's false. That's the other type of contact, normally closed, time closed. Right, that's basically we continue to use that concept in the PLC. Alright, so if you keep the trigger being true, this timer will just keep in this state forever, right? So because it's not timing, it's just a reset and waiting. And then if you turn the trigger off, remember this is a off delay, right? So the timer start timing, right? So let's see that. Maybe I'll change that to longer time, so give you time to look at that. Alright, so if I trigger this to off, you can see the accumulate start and enable is off, timer timing is true, right? Oh, okay, this is a wrong setup. I should use the exam off, right? Because you can see the enable, yeah, I can change that. So you can see that we can change to exam off, and then finalize, and that's supposed to be exam on, the opposite. I just copy paste from the on delay. I didn't change that, right? So let's see if that's the equivalent, right? With the TT bit. At least now it's true, right? So let me toggle this and clear that, right? So enable is on and timer timing is off, and this two combination is also off. Then when I trigger that to off, you can see, yeah, you can see enable is false, and then TT is running, and these two together is true. Right? Of course, you can use the only timer timing to do the same purpose, right? Then let's look at those two dumb bit again, right? Like right now, this is the normally closed, time closed, right? Because trigger is off, coil is de-energized, so that's closed. That's why you see the green bar highlight out here. Then when I start to energize the coil, right, when the coil is on, these two contact, they switch right away because it's off delay, right? When trigger is on, coil is on, they switch right away. There's no delay. The delay happens when the trigger become off, right? When trigger become off, timer timing start, it will wait 7 seconds, these two will flip. Like right now, they flip. Okay, so this is the operation of the timer instructions. Alright, let's look at the slides. Alright, so you just need to refresh your memory with your timer off timer. You will have the understanding of those two, right? So you will see that the done bit, right, represent the done, D-O-N-E. So timer output, if you use the exam on, that will be your normally open, timed open. Remember that's the symbol we use to represent in the timer relay. And if you use exam off instruction, you will have the exactly the same timing function with normally closed, time closed. Alright, okay, so I can finish this video right here.